Good people, Sanmonan, Makevalo. Now we are doing question 5 on the paper, November 29. Yeah, let's get into it. Here you're saying in the diagram below, P is K maps to 24, is a point in the second quadrant such that which is OP is 25 unit and ON is a point um is a point on the positive x-axis as OP or N is equals to theta. So if you can complete this triangle here, you can see that this triangle gives us right angle triangle, and OK is an x value here, and our y value here is going to be 24. As an opposite side, the hypotenuse side is 25. Calculating the value of k, we're going to use the Pythagoras theorem. How to use Pythagoras theorem is going to be r squared is equals to x squared plus y squared. My r is going to be 25 squared is equals to my x. Hopefully you can see that our x is on the negative side of the x-axis. So the value of k that we're going to find here is going to be the negative value of k. That is very important also. So it's going to be k squared plus my y is 24 squared. Now taking this to the other side, it's going to be 25 squared minus the 24 squared is equals to the k squared. Then we square both sides, we square both sides. So okay is going to be plus or minus 7. What is very important that now the value of k that we're looking for is the value of k that is negative. So negative 7. So the value of k here is going to be negative 7. So that is very, very important. The value of k is negative 7. And then 5.1.2. So I've written this down. It is very important. Your Sokatoa, it's very important to understand and to know this. So tan theta that we're looking for, we know tan is opposite over adjacent. So opposite over adjacent here. So tan theta opposite over adjacent is going to be 24 all over 25. That is opposite. Oh, that is opposite over hypotenuse, man. That is wrong. Opposite over adjacent, which is negative 7, negative 7. So going to the 5.1.3 to find sine alpha, if this is that, first let's say tan theta plus alpha is equal to 360. Now solving alpha is going to be 360 minus theta. So now coming back to sine alpha is going to be equals to sine alpha, substituting in alpha is 360 minus theta. Now from here, negative 360 minus is on the fourth quadrant and sine is negative on the fourth quadrant, so it's not going to be negative sine theta, and then now negative this negative, and then sine is open, so it's over hypotenuse. So my opposite here is 24 and my hypotenuse side is 25. That's why it's negative. This negative is this negative, has nothing to do with 24 over 25, but it comes back here and then give us the whole answer of negative 24 over 25. Now doing cos squared theta minus sine squared theta. Now cos squared we know is an adjacent or hypotenuse, so adjacent there it's negative 7 over hypotenuse, which is 25, and then all squared, and then minus sine is 24 over 25, and then all squared. So if I can continue this from here, we know that 7 squared is going to give us 49 all over 25 is 625, and then minus 24 all squared is going to give us 576 all over 625. Then from here, since I have the same denominator, is going to be 625 all over 49 minus 576. which is going to give us 49 minus 576 is negative 5 to 7 all over 6 to 5. So this is the last answer of this question here. So going to this one now is simplifying without the use of a calculator. So reducing this now, it's gonna be a cos of 180 minus 30, 180 plus 1, sorry, 180 plus 30, which gonna give us 210, and tan of 135, so it's 180 minus 45, so it's gonna be 180 minus 45, then all over here, sign of a negative angle, it's negative sine 60 times. Here, if you're getting a number that is about an angle that is above 360, just take that number, which is 420 in this case, we it by 360, then it's going to give us 60. You just say right cos 60. Here I say 420 minus 360, then I got 60, which I just put it here. You don't have to put to show it here. You just have to do it separately and then give us an angle there. So cos 180 plus it's on it plus it's on the third quadrant. Yeah, 180 plus on the third quadrant, and cos is negative on the third quadrant, so it's going to be negative cos 30, then times 180 minus is on the second quadrant, and tan is negative on the second quadrant, so we're going to have negative tan 45 all over here. It's going to be negative sine 60 times cos of 60. Now from here, special angles, so cos of 30 is negative root 3 over 2 times, this is going to be negative 1 all over negative also root 3 over 2 times cos of 60, it's 1 over 2. Then from here I can cancel this, cancels this, then the answer here it's negative 1 all over 1 over 2, which is going to give us negative 2. Now doing this one now, I have to prove the identity that our left hand side is going to be equals to our right hand side. So first thing here, we're going to deal with the right hand side. Hopefully we know that sine x over cos x is equals to tan x. Again, there's this thing here that we're saying cos x all over sine x is equals to 1 over tan x. The reciprocal of it is 1 over tan. Sine over cos is tan. Cos over sine is 1 over tan. Very, very important. So here, we're going to apply that same logic. So in this case, it's going to be cos squared x all over sine squared x, and then minus into the cos squared x. Remember, we're dealing with the left-hand side. Now from here, my denominator is 1, my denominator here is sine squared. How can I make those same denominators to be the same? I need to times here by this denominator to make it the denominators to be the same. So from here, if I can times by sine squared x all over sine squared x, then from here, I can say now this is cos squared x all over sine squared x minus, there is just going to be exactly the same as cos squared x, then sine squared x all over sine squared x. Now my denominators are the same. I can take one denominator, then it's sine squared x all over that which is cos squared x minus of cos squared x sine squared x. And then there at the top, we have cos and cos, which is a common factor. So we're going to have cos squared x into, taking this as a common factor, I'm left with 1 minus, this is also out. So I'm going to be left with sine squared x into all over sine squared x. Now here, I hope we know that this is the identity of cos squared. So it's going to be cos squared x into, this is cos squared x, and then all over sine squared x. And then there at the top, that and that is going to give us a cos fourth of x all over sine squared x, which is exactly the same as our right hand side. Hope we're still on the same page there. Now coming to this one, which is the general solution. So taking this cos to the other side, so it's going to be root 2 into sine x cos x, and then minus cos of x is going to be equals to 0. So from here, I hope you can see that this and this is a common factor. Now taking the common factor of cos x, going to be left with the root 2 and then sine x, then minus 1, then this is going to be equals to 0. So from here, we know that cos of x is going to be equals to 0, or the root of 2 sine x is going to be equals to 1. Now here, finding the reference angle, second function cos 0 is going to give us 90 degrees. Remember, this is a reference angle. So cos is positive in which quadrant? First thing, positive on the first quadrant. Remember, on the first quadrant, we take our ref angle as it is, so it's 90 plus k times 360, where k is an element of integers, and or also cos is positive on the fourth quadrant. Remember, on the fourth quadrant, we have 360 minus our reference angle, which is 90 in this case, and then plus okay times 360, and then 360 minus 90 giving us 270. So it's going to be 270 plus okay, and then times 360. Remember, we create an element of integers. Now coming to this one here, this is going to be sine x is equals to 1 all over root 2. So x is equals to, as a reference angle, now second function, sine over 1 all over root 2, which is going to give us 45. And also remember, this is our reference angle. Now sine is positive in each quadrant. First thing is sine is positive on the second quadrant. So second quadrant, we find 180 minus our reference angle, which is 45, and then plus okay, which is times 360. So what is 180 minus 180 minus 45? It's going to give us what? 135. So it's going to be x is equals to 135 plus okay times 360, where k is an element of integers. Or sine is positive also on the first quadrant. Oh, I forgot that. I started with the second one, the first quadrant, which is just 45 plus k times 360, where k is an element of integers. That was the last question of question 5. Thank you so much, guys, for watching. Make